for Daimler Trucks North America, and Steve Nadig, Chief Engineer of Mechatronics for Daimler Trucks North America. They will MC the demo that you're about to experience.
MC Derek, yeah.
DJ Rods.
And we also have Carrie Schaefer here with us still, General Manager of Product Strategy. And Peter is around. Okay, I would like to hand it off to Derek now.
Okay. Great. Thank you very much. Thank you very much, Paige. So what we have here planned today is a series of demonstrations. We'll perform 2 maneuvers today using the Detroit Assurance 4.0 package. One of those maneuvers will be a braking event on a moving object. The other one will be on a braking event on a stationary object. In this case, we have our inflatable car here today. And then in addition to that, we're going to perform 2 maneuvers as well with truck pairing, so doing some platooning maneuvers there. One of those will be a maneuver with a cut-in maneuver with the 2 vehicles in close following position. We have a third car that's going to cut in and brake to demonstrate how we handle that situation safely. And then lastly, we'll do also a braking event on stationary objects with 2 vehicles. So that's what we have in store today. I think if we could cue the first one to go.
Okay, Steve. Yeah, so I'm gonna. Every good team needs a straight man, and then somebody else to provide the benefit. So I'm the straight man today. What I'm gonna be talking to you about is current product, and the first thing that you're gonna see is braking on a moving object. We introduced braking on a moving object first in 2015 with Detroit Assurance 2.0, and it's in this product that you're going to see in Detroit Assurance 4.0. 4.0 also brings some additional features that we bring with this. We do have lane departure warning in this, and that's really another key feature that we're going to bring. What you're going to see is a truck up in front pulling along a sidearm, and then you're going to see the Cascadia following it, and you're going to see the braking on that event. Again, this is something that we've had out in production now since 2017, and the feedback that we're getting from our customers is really phenomenal. A lot of them have said you virtually eliminated accidents from their fleets. Some of them will tell you it's a ratio of 1 in 4 per year to 1 in 19 a year. That's pretty impressive. So this is the Cascadia following close to the moving object, and you see it start to put its brakes on. That's all done automatically, and then it's separated. So there you go.
Great. Yep. Thanks, Steve.
Yep.
So we're going to alternate back and forth just for the sake of efficiency. So we're going to start with our the pairing demonstration, which is the cut-in maneuvers. For some background, the pairing system is basically a fuel economy feature that we're developing for our trucks. Fuel economy, having 2 vehicles follow in close following proximity means that you get aerodynamic benefits. Today, a vehicle driving down the road at highway speeds, about half that power, that energy that the motor is producing is used to overcome drag. So aerodynamic drag is a big part of fuel economy. So that's the main focus on this project. But really what we're looking at now, our engineers are really focusing on making sure that it can operate safely in all those different driving environments. Because we are having 2 vehicles in close proximity, means we have to think about different driving scenarios to encounter and also respond to them. So these vehicles are under development now. They are a level 2 system, so that means they also have active lane assist. So we're providing input for both drivers to keep the vehicle centered in its lane. And we're also providing the braking features as well that will allow them to brake in a safe manner. And so with that, the 2 vehicles that are coming right now, you'll see they're currently being paired right now. When they become paired, we have a sequence of kind of like your mobile phone when you're pairing your Bluetooth. You have to have both vehicles acknowledged, and then they follow in this close following distance. And here you'll see the cut-in vehicle. Normally, a person wouldn't be doing too much of that, but but the point is that when we're on the highway, you're going to encounter a lot of different scenarios like that. And here you can see, for example, the following vehicle hit the brakes. and then increase the following distance as well.
So great, 4.0 on that rear vehicle, braking on a moving object, and then the adaptive cruise control took over and you can put it at a safe following.
Yeah, exactly. Those are building blocks that we build on top of. So I stand on the shoulders of giants. In this case, Steve.
He gets all the fun stuff to develop it, and then we get to bring it to production. So
right, exactly.
Again, we're straight man versus the.
This system, showed a system in Germany and Düsseldorf 2 years ago, I think.
Yep.
So are there any differences in this system? What are the...
From what you're seeing from the front end, no. This is all, and it's a great question because it hits exactly where I want to go. We put 1.2 million miles on 4.0 in the United States before we ever brought it to market. We developed that radar with our friends in Germany, our friends in Fuso. We had over 5 million miles on this system before we ever brought it to market globally. And the radar in and of itself, it's also an M-class radar. So we were working with our passenger car colleagues at the same time. So it's the same system, the same Detroit Assurance system is the same one that we're selling in Europe. But it's really important to tell, if I tell you that we develop them and regionally develop them. The bridges in the United States are much different than the bridges and the tunnels in Europe. All of those false objects and false detections, you need to put those kind of miles on the vehicle to really get it right. Yeah, so we spend a lot of time getting it right. So thank you for that question. So what you're going to see next is braking on a stationary object. We have over to our left our stationary object, the mock-up of the rear end of a vehicle. And you see a Cascadia Next Gen coming down the road to brake on that. We're, I believe, the only OEM who offers full braking on a stationary object. So we'll ask the brakes to give us all the power that we can get out of the system so that we bring the truck to a safe stop. It is a collision mitigation system, not a full avoidance system. But there you see we've detected it and stopped it. And we've been able to bring it up to speeds above, around 45 miles an hour or above to be able to ensure that we get full stopping. So it's a very, very impressive system. Don't know, I would guess it looked about closer to 35, but that's my eyeball. Yeah.
So the truck stopped it. His hands
were on the wheel steering it, but his feet were not on the brakes. Yep.
Okay. Does cruise have to be active?
Yes, it's part of the adaptive cruise control. Yeah, it's adaptive cruise control is the comfort feature in there, and then the safety feature that we have is, I shouldn't say that. It doesn't for the collision mitigation portion. It does for adaptive cruise control. You can have it off and you'll still get the collision mitigation. Yeah.
So if his foot's on the accelerator, it'll override that and brake?
You can. The one override that we do have in the system is throttle. You have to go from a non-full wide open position to a full wide open position in order to override it. So that's the one override that we do have in the system, so the driver can take control of the system if need be.
Okay, but otherwise it's braking.
Otherwise, yeah, it's going to brake.
Okay.
Yep.
Maintain steering control? Does the driver maintain steering control?
That one, the driver was in full control. There's no augmentation of steering whatsoever.
ABS accurate?
ABS, yep.
That's correct. So building off of that, we're going to perform a similar demo with truck pairing here today. We can start the demo right now. It'll be the similar scenario that Steve had mentioned before. We'll have the full braking capabilities. Again, these vehicles do have the active lane assist, so they've got that second level of safety built on top of it. And then one aspect with truck pairing is the vehicle-to-vehicle communications. So they are sending messages to each other wirelessly, like Wi-Fi, every 20 milliseconds. So the lead vehicle will know the following vehicle will know that the lead vehicle is braking almost instantaneously. And as you'll see here, that when they hit the brakes, they'll do a coordinated braking event. And so as you can see, they both pretty much brake in unison. That's thanks to the vehicle-to-vehicle communications, and that's another use case that we're looking at to ensure safety. Safety is really something that we can't emphasize enough when we're looking at these systems. We want them to be on the road to improve the safety on the roads. We want to make sure all of our systems like clearing act in a safe manner. And so we're looking at well over 50 different types of maneuvers. These are only two of which that you've seen here today. Which is why we're still continuing to do the R&D work, which is why we still continue to investigate what the possibilities are. So there's still a lot of work ahead on that project.
It's like what you said though earlier in your earlier presentation. It was like synchronized swimming. They maintained exactly the same distance as they went through the braking event.
So the audible, that was part of the
Yep.
braking process?
Yep. That's part of when it gets close enough to the vehicle, we'll turn on the flashers and we'll honk the horn. It's actually part of the integration, and nobody else does that type of integration also. But that's one of the things that we see as a value that we bring, is that deep integration that we're able to do. So, yep. Any other questions?
Do we have any more questions? You can have a few more, of course.
Yeah. We're here.